Imagine venturing deep into our planet, past the roots of towering mountains and colossal canyons. As we descend, the ground beneath us grows warmer, the air thicker. Our journey takes us through layers of rock and metal, each with its own story to tell. Finally, we arrive at the Earth's inner core, a place of immense pressure and unimaginable heat, where temperatures rival even the surface of our sun. This extraordinary heat, thousands of miles beneath our feet, plays a crucial role in shaping our world. It influences everything from our planet's magnetic field, which protects us from harmful solar radiation, to the very continents we live on. Understanding the Earth's inner core is about more than just knowing what lies beneath. It's about comprehending the forces that have shaped our planet and continue to influence our lives today. Before we can delve into the heart of our planet, we need to understand its structure. Imagine Earth as a giant onion, composed of distinct layers, each with its own unique properties. The outermost layer, the crust, is where we live, a thin, rocky shell compared to the Earth's massive size. Beneath the crust lies the mantle, a thick layer of hot, dense rock that churns slowly over millions of years. This churning is responsible for the movement of tectonic plates, leading to earthquakes and volcanic eruptions. Deeper still, we encounter the outer core, a sea of molten iron and nickel. This liquid metal, constantly moving due to Earth's rotation, acts like a giant conductor, generating the magnetic field that shields us from the sun's harmful radiation. And finally, at the very center of our planet, lies the inner core. The inner core is a sphere of solid iron and nickel, about 1,500 miles across, slightly smaller than our moon. It exists in a state of extreme pressure, over 3.5 million times the pressure at sea level. This immense pressure, combined with the intense heat, forces the iron and nickel atoms to pack together so tightly that they can no longer flow as a liquid, forming a solid despite the extreme temperatures. The inner core is a place of intense scientific interest, yet it remains one of the most inaccessible and mysterious places on our planet. Its immense pressure and scorching heat make direct observation impossible, leaving scientists to study it through indirect methods, such as analyzing seismic waves generated by earthquakes. The inner core is incredibly hot, with temperatures estimated to be around 5,200 degrees Celsius. Where does this intense heat come from? Part of it is residual heat from the Earth's formation billions of years ago, when our planet was a swirling mass of dust and gas. As this material coalesced, gravity pulled it together, generating immense heat within the Earth's core. However, the primary source of the inner core's heat is radioactive decay. Deep within the Earth, radioactive elements like uranium, thorium, and potassium decay, releasing energy in the form of heat. This constant radioactive decay acts like a giant nuclear reactor at the heart of our planet, keeping the inner core scorching hot for billions of years. Feeling the heat-temperature gradient of Earth. As we journey from the Earth's surface to its core, we encounter a dramatic increase in temperature, known as the geothermal gradient. On average, the temperature rises by about 25 degrees Celsius, or 77 degrees Fahrenheit, for every kilometer, which is about 0.6 miles, of depth. This means that even a few kilometers below the surface, temperatures can be hot enough to boil water. The geothermal gradient isn't uniform throughout the Earth. It varies depending on factors like the composition of the rocks, the presence of radioactive elements, and the proximity to tectonic plate boundaries. For instance, areas with active volcanoes often have much higher geothermal gradients than other regions. Like two peas in a pod, inner core versus Sun's surface. The Sun, a giant ball of burning gas, has a surface temperature of around 5,500 degrees Celsius, or 9,932 degrees Fahrenheit. Amazingly, the Earth's inner core, though much smaller, has a temperature almost as high, around 5,200 degrees Celsius, or 9,392 degrees Fahrenheit. This incredible heat deep within our planet has profound implications for life on Earth. While the Sun's heat and light are essential for life on Earth, the heat from our planet's interior drives the movement of tectonic plates, shapes continents, and fuels volcanic eruptions. These geological processes, while sometimes destructive, are also responsible for creating the diverse landscapes and ecosystems that support life on our planet. The core's influence, more than just heat. The Earth's inner core plays a vital role in generating our planet's magnetic field. As the liquid iron in the outer core flows around the solid inner core, it creates electric currents. These electric currents, in turn, generate a magnetic field that extends far out into space, forming a protective shield around our planet called the magnetosphere. The magnetosphere acts like a giant shield, deflecting most of the sun's harmful radiation, known as solar wind. Without this protective shield, life on Earth as we know it would be impossible. The solar wind would strip away our atmosphere, bombard the surface with harmful radiation, and make Earth a barren and inhospitable world. Unraveling Earth's mysteries. The Earth's inner core, a place of immense pressure and unimaginable heat, remains one of the most enigmatic and fascinating parts of our planet. While we have learned much about its composition, structure, and role in shaping our world, many mysteries remain. Scientists continue to study the inner core, using sophisticated techniques to analyze seismic waves, model its behavior, and unravel its secrets. Understanding the Earth's inner core is crucial not only for comprehending our planet's history and evolution, but also for predicting its future. By studying the dynamics of the inner core, we can gain insights into the processes that drive plate tectonics, influence our planet's magnetic field, and ultimately shape the world we live in.